This meeting is being recorded.
All right, so this meeting is being recorded. Chris, take it away.
Thanks, Jess. Kia ora koutou katoa. It's welcome to everyone, and thanks for coming along to this presentation. It's kind of weird. It's a bit like talking to myself because I can't actually see anybody except Jess, but that's fine. That'll suffice. I'm honoured, pleased to be presenting to the New Zealand chapter of INCOSE, and I do see a number of familiar names and some of you for the first time. Greetings to everybody. So my presentation is entitled the P-3K2 Orion, a systems engineering retrospective, or perhaps more relevant, how I became a systems engineer. I believe I've got about 30 minutes, but as this is the first time I've done this kind of thing, I'm likely to be either way too long or way too short. The upside is that nobody has to travel home, right? We're all probably already there. So when I joined Beca, I didn't know how to spell systems engineer. Now I is one. A bit about me though. I'm a mainlander, Cantabrian, which means I've got one eye shut and the other one doesn't see very well when it comes to rugby. I went to school in Christchurch, studied agricultural science of all things at what was then called Lincoln College, now a university in its own right. I joined the Royal New Zealand Air Force in 1987 at the ripe old age of 24, just sneaked in under the age limit. I learned how to fix planes, how to fly planes, well, briefly and partly. I didn't get through the course, and learned how to operate systems on planes as an air electronics operator and an air warfare officer. My career focused on the P-3 Orion and on number 5 Squadron, who really feel to me like my whānau. It has been a lifetime, it feels like, of engagement with them. I had 2 flying tours, about 2,000 odd hours, and I truly got to see the world with 5 Squadron. Along the way, I had a few other jobs. I was adjutant at RNZF Base Woodburn for my sins quite early in my career, so I was quite bad, quite young. 2 years in Penang, Malaysia, as training officer for the Integrated Air Defence System. Flight commander of the TACCOMS flight, officer commanding of the operational software maintenance unit for about 5 years. That was for the P-3K, so that was the predecessor of the K2. And then about another 5 years as staff officer of maritime patrol in the headquarters. And along the way, I did 6 months in Sudan, working for the United Nations, and that was an experience that is a presentation all in its own right. Just in case you don't know who Beca is, we're a professional services business based in New Zealand, with offices in the New Zealand, Asia Pacific, and further afield. According to this wonderful graphic I've got here, 4,000 plus people, 14 countries, 25 offices, 75 disciplines, 75 plus disciplines. I suspect systems engineering is the plus. We're Beca Applied Technologies is a subset of Big Beca, 60 systems, software and security engineers. Thanks for that quote, Jess. So we account for less than 1.5% of the number, but we do in fact do the coolest stuff. But enough about Beca, let's talk about me. I didn't start my career knowing much about systems engineering, but along the way, I undertook a significant body of training, made extensive use of having a training budget for both myself and the team around me. And we were, in the end, well-versed in both doctrine and practices associated with systems engineering. Learned how to write specifications, learned about the RTCA DO 178B software assurance guidance as it was when it was B. Later on, you'll see I did a differences course about 178C when it became a standard. Did an E3 course, did some systems engineering training, requirements writing, requirements management, which is pretty much the same course. Whoops, same course with, I know I'm just giving you all my slides. Whoa. Showing my secrets before we get there. Test writing, Systems engineering management, safety analysis, that was quite cool. That was in Cranfield University in the UK. Some process change management, and my favorite, which is I missed out in the middle there, which was my cognitive systems engineering course that I did in Australia, where we got to talk about things like information aggregation, cognitive transformations, human machine transactions, etc., etc. All very cool stuff. And while reflecting on my association with the P3, this slide, by the way, is supposed to convey a lot, and it may not necessarily be entirely readable, and I apologize for that, but I'm going to talk to it. I realized that Beca Applied Technologies has been involved in pretty much the entire life cycle of the P-3K2 mission system, and I personally haven't been involved right from the outset. I've seen a complex integrated system through all the stages of its life cycle, starting with the problem definition and requirements analysis phase while I was still in the Air Force. And there's at least one other person, potentially two, in this audience who were part of that process as well. And culminating in the end of service and disposal of the aircraft with the activities that are currently underway for archiving and disposing of componentry and of engineering data. The Beca Applied Technologies team that I'm so proud to be part of has done some pretty cool stuff within this context. We started off by embedding 7 engineers with the OEM in the USA, in Texas, no less. And they participated in the design, implementation, and component testing and integration testing of the delivered system. We aided the RNZAF to design, set up, and configure the new support facility for the mission system at Whanuapai. We assisted with the introduction into service of both the aircraft and its support systems. We worked alongside the RNZAF to develop an appropriate lifecycle support model and walked alongside them as they developed their own capability in both aeronautical software and complex systems engineering disciplines. We conducted ongoing fault definition and safety analysis on the identified defects, and we assisted the OEM in warranty defect isolation and rectification. Through this, we helped the RNZAF to better understand the functioning of the complex system that the P-3K2 mission system was, and aided them both in its operational use and also in their technical support of it. To further support that, we built tools to optimize workflows, leverage outputs from the system. We maintained and enhanced the mission simulation and training systems to aid in aircrew and technical training. And, pièce de résistance, we produced a series of 8 major software updates that variously optimized the existing system functions, added new functions, improved system performance, rectified defects, added entirely new sensors, or upgraded existing sensors that were already a part of the system. And lately, we conducted obsolescence analysis and integrated replacement system components as obsolescence started to take hold. We even spent time with the Air Force on deployment to better understand their mission and identify ways that both the physical system elements and the human elements of the system might be employed differently to achieve a better effect. And we are assisting now in the closeout of the engineering processes, as I said before. We've stood alongside the Air Force throughout this entire time, both as a repository and caretaker of the evolving system understanding, ensuring that lessons and knowledge were not lost through the passage of time and the attrition of Air Force personnel. And just talking directly to the slide for a second, that isn't the full set of system lifecycle activities. It's a key set that was sort of mentioned within the wordage that I just put in front of you there. And in fact, some of it has slipped off the bottom of the screen on mine. I don't know if it is anyway, but we as well as the data management system, we were supporting the initially what we were calling the CSIL, the Commercial Software Integration Lab, which was an environment that we were using to do our initial software testing and integration using commercial off-the-shelf hardware rather than any of the actual aircraft hardware. The System Integration and Training Lab, which was a set of racks that roughly were a rough facsimile of the layout within the aircraft and included all of the aircraft components so that we would be able to test our software changes and any integrated new system components in the final hardware environment, and that minimized the amount of actual aircraft testing we had to do. We also had the mission simulation subsystem, which we were supporting and developing throughout its life cycle, and the flight deck trainer, and the mission planning and analysis system, which has slipped off the bottom of the slide, I see. All of those integral activities along the right-hand side were over and above and had to be considered, and at various points were preeminent in terms of the work that we were doing at the time and depending on the stage of the life cycle. We'll talk to a couple of those a little bit later on in the slides. But right now I'm going to talk a little bit about the team. And no engineering presentation would be complete without a graph or so. And so I've combined 4 into 1 slide. I dredged some data from the Beca system to show a little bit around the shape of the support that we provided to the RNZAF. This is showing the roughly, it was 14 years, but it was 15 years from 2008 to 2023. The last year's data hasn't been aggregated onto this slide, but you can see that we started off, if you look at the staff numbers in blue, with a mere 7 people at Whenuapai. In fact, it was 6 when before I began, and I joined a couple of months after the unit was set up. We expanded pretty rapidly, and at its high, there were 46 different people in 2018 who contributed towards the job. If you look at the yellow, you can see how that equates out into full-time equivalent. And we negotiated the full-time equivalent delivery on an annual basis within the framework of our fixed contract. So we had a 5+5 contract with a full review at the 5-year point. It rolled through the 5-year review. We went through to the 10-year point, and then we got a 5-year contract to follow on from that. That took us through to the end of life for the aircraft. At its peak, and you can't really see that here because it says 19.8, we were actually at 21. That's just the maths, and the numbers weren't quite correct. We had 21 people on our full-time team at Whenuapai when we were deep in the throes of major software change and major hardware obsolescence integration for the aircraft. So as I said, it was 15 years of support. If you add the 4 years that were spent in Texas, that's 19. So nearly 20 years of supporting the P-3K2 mission system. The aircraft itself on retirement had done over the fleet had done over 148,000 hours of flying. And I estimate, based on approximately 2,000 hours a year, around 30,000 hours of that was by the P-3K2 variant, the one that we were supporting. And when you look at the dark green line, you'll see that over the course of the contract, we've delivered 32,000 hours of support effort to the RNZAF in order to enable them to keep flying that aircraft and keep improving that aircraft to meet the operational outputs required. That's a bit startling when you look at it. I won't do the maths to tell you how much that cost the Air Force, but I can tell you, you wouldn't have found a cheaper software contract of that sort anywhere in the world, let alone in New Zealand. But you know, that's when we were looking at this, we were taking a big risk, and so the Air Force took a big risk as well, and signed up for 10 years, and ended up being 15, and we're very proud of that achievement. Over 100 current and former Beca staff have contributed, 50-50 split between software and systems engineers, 6 major software releases, 2 major hardware obsolescence upgrades, 2 new sensor integrations, and as I've said before, we even spent time with them on operational deployment. And that was an interesting point in the life cycle of the system, where we actually got to see, in fact, when the Air Force 5 Squadron actually got to exercise most of the capability that was inherent in that aircraft in anger for the first time on their deployments to the Middle East. And there were a lot of things that were coming out of that in terms of issues that they were facing. And we suggested at one of our monthly contract meetings that we may be able to help if we could get more information about what they were doing and seeing how they were operating it. But of course, it's all classified. And the only way that we could do that was to be present. And lo and behold, that's what happened. 2 of us got issued some camouflage gear and a pair of sunglasses, and we went and spent about 8 days up in places sandy and hot. And I flew 5 or 6 operational sorties, while my offsider, software engineer by the name of Peter Brazendale, spent a lot of time sitting with the ground element of the deployed team. I was with the airborne element, and between us we sat down and dealt with, I think, about 15 to 20 different aspects of how the system was being used that were either completely unexpected, they were using it to do things that we didn't know they were using it for, or not to put too fine a point on it, completely wrong. They weren't using the system the way it was designed to be used, and therefore they were making life hard without intent. It's just that it was the first time that these things had been put together in an operational scenario, and they were doing the best they can with the knowledge they had. So that was a really exciting phase in our engineering support. The recommendations that came out of that deployment fed an entire major software release, which followed shortly thereafter. So one of the key early hurdles that we had to overcome when setting up the support operation was we needed to define and establish the required process. By the way, I do not expect you to be able to read the words on the right. That's showing you complexity more than anything else. With the introduction of the support for the K2, we were introducing both systems engineering and RTCA DO 178B software assurance to the Air Force, who at the time were new to both. In truth, so was Beca, but we learned alongside them. And it was our job to get ahead of the game, to bring the skill set up, to get the capability to support the aircraft fully functioning by the time the first aircraft was delivered. We were aided in that endeavor by the fact that the first aircraft, which was due to arrive in late 2008, didn't actually arrive until, Marty, help me out, was it 2010? And I think wasn't declared operationally ready until 2011. So we had plenty of time, which was a good thing, because it was a complex and heavy process that that was initially developed. Of course, everything was going to be waterfall, using the systems engineering V model, and overlaying DO 178C assurance, and on top of that, trying to mirror the MIL standard 498 project process with all of its steps and all of its DIDs. But as time went on, both we and the Air Force were very keen to reduce both the time and the cost associated with such a heavyweight process, and to optimize throughput, to get more change through the change process and onto the aircraft, to fix more defects, to add more capability. Just looking at that picture on the right, all of the colored rectangles were reviews. We had that many different review points throughout the process. And the column that is labeled products, that is all of the outputs from our process. And all of those had to be put through their own review process. And so we spent an enormous amount of our time, sorry, I feel like I don't know what I'm doing. Should I go up? No, down. We spent an enormous amount of our time sitting around the review table, and eventually that it became clear that that wasn't going to be sustainable for the level of change agility that the Air Force was going to need. Just let me catch up with myself. And so the Air Force, we worked with the Air Force to start to optimize our process. You would have seen on that busy blue slide that was higher up, one of the things that was in there was a continuous improvement program. Throughout it all, we were looking constantly at ways that we could either combine or remove steps completely, where we felt that they added no value or that they were being met through other mechanisms, and the process got leaner and leaner. We adopted standing plans, so we didn't have to regurgitate and put through a full review process all of the plans that we needed for a DO-178 software process. We published them, got them accepted, and only if we needed to make changes were changes made to those documents, and it was the changes that were reviewed at the start of the next project. We had better and better engagement with the certification authority, which was a cell within the Air Force that grew organically from a beginning of, I think it was 2. Russ McMullen may have been in that very early team, one of the people in the audience. And as that experience was developed and engineers were being put through training, including we had a junior engineer from the Air Force embedded within the software support and system support area that we were part of, so that they could learn how to spell 178, learn how to speak systems engineering, and be able to understand what was being done. And eventually we were able to make some real gains in terms of making the process efficient and effective at the same time, and continuing to maintain the level of safety that's required with aeronautical software. The other thing that was a significant contributor to that was developing the relationship with the certification authority, so that we were not so much throwing our products over the wall for them to put through some arcane review process and then throw back a bunch of information requests, but instead they came and sat with us, and we talked them through the outputs from the process that they were interested in, answered their questions directly, satisfied their concerns, and significantly reduced the effort that was required to get certification approval at each of the gateways. Along with that, we were operating an active risk management program. And so that was both a safety risk management through the DO-178 process, where all software changes were put through a safety risk assessment. That evolved significantly over time, and that was a lot to do with the RNZAF's growing understanding of what they meant by system safety, and what they needed from an assurance perspective with regard to system safety. It is one of the most difficult aspects of it was one of the most difficult aspects of the program, was the fact that we are required by 178C to put any changes to the system through a safety assessment process, which would normally be contingent. The safety assessment is based on the platform level safety case and safety assessment that flows down from that, and there was none, which meant that the process of doing safety assessment became a bottom-up process, and as a result was quite subjective, required a significant amount of knowledge of how the system was intended to be used. And early on, that knowledge was not as easy to come by as it could have been, but that's largely because there were not that many people who had been through the training and who had enough flying on the system to understand how things interacted. That being said, that process worked well, and there were no safety incidents that resulted from that process. However, it was always a little uncomfortable that we didn't have a high-level safety case or a high-level system safety analysis from which we could then distill the safety impact from our software changes. Yeah, as I said, in that picture up there, you can see that the coloured boxes are reviews. There's 16 in total. By the time we did the final software release, that was just reduced to 5 major reviews, review points. We were doing iterative integration because we were integrating hardware changes as well as software changes and feeding that back via the safety assessment process into the software change process, and then rolling back into integration testing and then final acceptance testing at the end of that. Much more efficient. We still only managed to roll out a software release about every couple of years, but we got a lot more out in our software releases, I believe, than would have been possible if we'd stuck to the heavyweight process that we started with. So some of the challenges that we faced in this, obviously, and I've mentioned this already, we were introducing new processes and new standards, and they were new to us, as well as new to the client, to the Air Force. We had, we believed, and we've subsequently, proven right, that the Air Force would do well to put its trust in us. We made absolutely certain that we put our people through the training. You would have seen that from the list of courses that I myself did, and plenty of others were doing training at the same time. The idea being that we would rapidly gain the textbook knowledge and along the way the experience that comes from actually doing the job and turn that into expertise. And we certainly did that on both sides of the fence. Both the Air Force and Beca Applied Technologies have moved massively forward in the area of systems engineering and in high integrity systems engineering. As I said, we had no platform safety case, which made one of the integral components of software change at all levels in 178, that of safety analysis, a little tricky. But we overcame that through some creative, some compromise, and I think another member of the audience, Harley James, was instrumental in getting the first couple of those over the wire. Quite a long and drawn out process as we sought to understand the system and how the system was going to be used, and I'm talking about the mission system here, but nevertheless laid a good foundation for us to be able to go forward, and we essentially did the same thing for every project from then onwards. Harley used to be my client. Now he's my boss, and there should be an advert about that. I think, what was that one? Was it toothpaste? No, it was a shaver. I loved it so much I bought the company. Well, kind of the opposite. But that tells you a bit about the relationship that we developed with the client. That we almost had a permeable kind of a boundary between the two, and we weren't breaking any lines in terms of poaching. We had such a relationship that we all felt like we were in it together. I've stepped out of the hard bits and talked to something that's on the next slide, but I'll come to that. Another significant set of issues that we faced, particularly early on, was that we were dealing with OEM documentation, including requirements that had not been maintained since they were delivered as DIDs at the point in the project, the program that they were required. And so requirements, the final set of requirements were required for the critical design review or the final design review. And from that point onwards, there was most definitely change to system design, which would have flowed back into requirements change. And there were things that were traded out that were not in the system that were still in the requirements, things that were new in terms of function that had not been written up into the requirements. And because requirements were the fundamental building block for developing the software in the first place, and then subsequently developing the tests for the system, that gave us a significant amount of work that we had to do in the early stages of choosing which parts of the enormous requirements database and doors we were going to endeavour to bring up to the current state. And we always had this dichotomy between the bits of those and same with the other design documents, things like the interface control documents that specified all of the layouts for the HMI, etc. Signed off at CDR, but changes were made during the integration, the final acceptance testing. There were subsequent changes, and they didn't flow into the documents. And so we had to do a lot of work to bring those documents from where they were put down by the OEM and where we were picking them up. We didn't go do the entire set. We didn't feel, and we, and nor did the Air Force feel that that was going to be value for money. It added nothing, but what we'd had to have was a sound requirements set and sound design documentation set for the pieces of the system that we were modifying, or the places that we were going to make change. A big one was that we didn't know what we didn't know. In the early days of the system design, system implementation in Texas, we had, as I said, we had 6 people on the ground in Texas, but there was more teams than that. And even within the teams, each of the software engineers was only working on a part of a subsystem potentially. So there were elements of the systems that we didn't have any expertise in. And if you go back to the issues with the documentation, that sometimes meant we had to do, we had to essentially reverse engineer the question of how does this system actually work by going through the source code, looking at the decision flow path and working out what was actually going on. That was fun apparently for the software engineers, not something that I myself got into. Not a point of pride so much as a point to notice that I never claimed to be a software engineer, and I've never written a line of code. What I did was manage a major systems engineering project that involved software change. And if you were to look back at the size of our team, if you recall, we went from 7 people initially to about 16, and from there we went up to 21. The bulk of the increase was systems engineers. We started off with, when it was 6 software engineers and me, systems engineer, and I couldn't even spell systems engineering at that point. And by the time we got to the peak of our size, we had about 50-50 of the 20, so 10 software engineers and 10 systems engineers. And at times it was even more systems engineering heavy than that. We also had to encounter the tribulations that are associated with working in a classified environment, the security of the systems, the security of the software development system, the requirements under the US trafficking in arms regulations, which meant that we were not only responsible for the safety and integrity of the data, thereby the safety of the system. We were also responsible for the security of the information on behalf of the Air Force. We spent most of our working days inside secure areas, working on networks that had no connection to the outside world. We weren't able to have any personal communication devices, which personally these days I think is a bit of a bonus. No cell phones, nothing that radiated, and there was no connection to the outside world. In about the last 6 years, we introduced the ability to use specifically modified Beca laptops to enable us to have company communications at our desktop. Part of the problem with the security was that the Air Force was a little bit schizophrenic in regards to security. There was a hard and fast set of rules and in a classifications guideline document that was put out. And we were bound by our contract to follow that explicitly and at times implicitly, because it was a little bit internally contradictory. But most of the rest of the Air Force had never even seen that document. And there were numerous occasions where people needed to see data that we had and information that we were responsible for, but we were unable to provide it to them because of a classification that was on it, and they could not understand why. Yeah, we had to work our way through that. By the end, I think everybody understood and it was working pretty well. But in the early stages, it was a little bit of a stumbling block. Another thing that was quite difficult at times was the rate of turnover in our key clients contact. You know, we had a zipper engagement with the RNZF engineering world. And our people stayed reasonably constant in terms of who was doing what and in what role. But those of you with any military background or military knowledge know that the military likes nothing better than to post people as soon as they get to be an expert and able to implement a bit of change, and you step back and have to induct a whole new set of people into how things are operating and what the whole project is about and what the process is and why we can't do some things and why we have to do other things. That was as sometimes an exercise in resilience, but in other times it was a really refreshing opportunity to have a look at what we were doing. To ask ourselves the question of, are we doing it just because somebody said we should do it, or is there still a good reason? So they kind of acted as a bit of a review point as well. And perhaps last but not least, and obviously from my perspective, having a 30-year engagement with the aircraft, it was really hard to see the aircraft retire. And that is the downside to to being engaged through the entire life cycle. You have to see something go out of use, and all of your work is no longer being put to good use. The best bits. Up the top there, I say living with the client. We were embedded. We were inside the client's, the Air Force's engineering organization. We were acting as a part of an Air Force unit. We were engaging with them both as a contractor and also as colleagues. And that was a very stimulating environment for a high performance, high functioning teams to grow. So that was really cool. Right up there with that was the fact that we knew we were solving important problems. We were making a difference in the things that we did. We weren't just changing the color of logo on a banking app or fixing a back end glitch with a database in an HR system. This was stuff that was contributing to the safety and security of people and the confidence of our government and the New Zealand Air Force. Right up there with living with the client also was learning and growing alongside them. So we started this journey at the same level and we grew in tandem in terms of our proficiency, our flexibility and our expertise. And that's been really cool. And watching that as Air Force people, having said that they moved on super quick, they also, a lot of them moved on and up and holding key positions within the organization. And that's really cool to see as well. And lastly, done it again. Oh, look at those beautiful people. Taking a bit of a leaf from an old Maori proverb, he ata te mea nui o te ao, he tangata, he tangata, he tangata. You know, what is the most important thing? It's the people, it's the people, it's the people. And definitely for me, that has certainly been critical in this whole process. And I'm not just talking about Beca people. And here's when our team was at its peak. But as I said, you know, we lived and breathed Air Force and 5 Squadron at the same time as we lived and breathed Beca. The relationship that we had was founded on mutual trust. Along the way, we shared tribulations and also celebrations. So you can see us here celebrating the completion of our 10-year contract, and at that point rolling forward into the next 5 years. Together, we built a systems engineering capability for New Zealand Inc. from scratch, and both Beca and the Air Force now have significant capability. Point to note, or a point of interest, at least from my perspective, is none of the Air Force people that are in this photo are the same as the people that we started with. Although 4 of them do now work for Beca. 6 of the Beca team that were there at the start of the contract are still working for Beca. And we're pretty proud of the fact that people stay and people enjoy the work. And like I said right at the start, we do the coolest stuff. So I guess to round out my retrospective, the P-3K2 has been retired. The 19 years of Beca support to the P-3K2 has come to an end, but that is not the end of the story. We're proud that at this point, the RNZAF are well placed to welcome in the new generation of aircraft into service. Beyond the RNZAF, Beca has drawn on our experience with the P3 to branch out into other similar high integrity systems, software engineering services. You can tell I'm reading it from lines here, can't you? This includes work for the Navy, the Army, and the information warfare branches of the New Zealand Defence Force, and the growth of the defence market and services in Australia. We've also extended into other markets and clients, including rail, health, civil aviation, and even into space. And that's something that we could only have dreamed about in 2004, when the first people were sent to Texas to start work on the P3 project. So as sad as it is to bid farewell to the P3 and to be finishing that up, Beca has its eyes on the next horizon and beyond. We can continue to forge ahead in the world of systems engineering with the capability that we've developed, and ultimately to be making every day better for our clients. Oh yeah, and that's why I can now call myself a systems engineer. That's the end of my slides, ladies and gentlemen. Well, it's only one lady, unless someone's arrived and I haven't seen. May not have been exactly what you were expecting, but then it wasn't exactly what I was expecting either, because half of what I wrote wasn't what I said. But I am totally open to take questions, and there's too many people in the audience who know the answers potentially for me to tell lies, so expect complete honesty.
We do have a few minutes left. Thank you, Chris. So if there are questions out there, we invite you to put your hand up. If you want to stop your screen share.
Stop share.
Great.
And camera on? No, camera on.
Yeah.
Yeah.
Give it a moment. Not seeing any hands go up or any mics come off mute. So Chris, I'd like to thank you for an excellent presentation. Seeing the life cycle of the P-3K2 through a systems engineering lens and Beca has been really just fascinating. So it's great to have seen that, and really appreciate you pulling that presentation together today. So
Jess.
you're welcome. So I'm gonna do one last thing here, and then we'll wrap up. So that should still be sharing. Very good. So again, our next meetup will be in May, the 16th of May. Richard Fullalove from Transport New South Wales will come and speak to us. The exact title and topic are to be confirmed. But Richard's done quite a bit of work in systems engineering in the transport space. And that is, I think, going to be pretty cool to go and see. And then finally, as always, this is ways you can connect. Contact emails over there on the left. Mailing list is definitely something. If you're here, you probably got it. But encourage your colleagues to sign up as well. The Slack workspace, we do still use that for communications. And at that point, I'll just stop here and thank you for your time and attention. And thank you, Chris, for your presentation. Cheers, everybody.
Yeah, thank you very much.
Thanks, Jess. Thanks for sharing, Chris. Great.
Great
Nice
presentation, Chris.
Cheers.
Cheers.
Thanks, Chris.
So,
Thank you.
Thank you, Jess, for organising this.
Oh, good.
Yeah, thanks, Jess, as well. To appreciate all your efforts.
You're welcome. See you next time, everybody.
Thanks, guys. That was awesome. Good to see.